Have you ever wondered if a simple blue dye could hold the key to understanding and treating complex neurological conditions? Prepare to be amazed as we delve into the fascinating world of methylene blue and its profound impact on the brain. Methylene blue, often abbreviated as MB, is a remarkable compound. It's highly lipophilic, meaning it loves fats. This unique property allows it to easily cross the blood-brain barrier, a protective shield that typically prevents many substances from entering the brain. Once inside, MB can accumulate in brain tissue at concentrations even higher than in the bloodstream. This characteristic makes it particularly interesting for neurological research and potential therapeutic applications. This is a common question, and the answer depends on the context. In specific experimental settings, especially with higher doses or direct injection in animal studies, methylene blue can indeed stain certain brain cells. For instance, it can selectively highlight Purkinje cells in the cerebellum and nerve cells in the hippocampus. This staining is a powerful tool for scientists. It allows them to visually examine neuronal structures under a microscope, a technique that has been used for decades to study the intricate architecture of the brain. However, it's crucial to understand that this visible coloring is primarily a histological phenomenon observed in laboratory settings. When methylene blue is used in typical clinical or therapeutic scenarios, such as oral or intravenous administration for conditions like methemoglobinemia or neuroprotection, it does not visibly color the brain. You wouldn't see a blue brain externally or on imaging scans. The doses used in these settings are much lower than those used for experimental staining. The blue color of methylene blue is due to its oxidized form. Interestingly, the compound can change between its oxidized and reduced forms, and these color changes have been utilized in research to monitor neuronal activity. So while it's a powerful research tool for visualization, its therapeutic use doesn't lead to a visibly blue brain. Beyond its staining properties, methylene blue is gaining significant attention for its potential therapeutic benefits, particularly in neuroinflammatory conditions like multiple sclerosis, MS. MS is a chronic, debilitating autoimmune disorder affecting the central nervous system. It leads to demyelination, axonal injury, and neuronal damage, profoundly impacting a person's life. Current treatments for MS, while helpful, are often only partially effective. This highlights the urgent need for new, more potent therapies. This is where methylene blue enters the picture, showing promising results in preclinical studies. To study MS, scientists often use an animal model called experimental autoimmune encephalomyelitis, or EAE. EAE mimics many aspects of human MS, including inflammation, demyelination, and neurological deficits. It's a critical tool for testing new treatments before they can be considered for human trials. Research has shown that methylene blue treatment can significantly reduce the severity of EAE. It inhibits the development and progression of the disease, offering a glimmer of hope for future MS therapies. One of the key ways methylene blue exerts its protective effects is by mitigating inflammation. In EAE models, MB treatment has been shown to reduce inflammatory infiltrates, which are immune cells that invade and damage brain tissue. It also lessens demyelination, the loss of the protective myelin sheath around nerve fibers, and reduces axonal loss, which is damage to the nerve fibers themselves. These anti-inflammatory actions are crucial for protecting the delicate structures of the central nervous system. By calming the inflammatory storm, methylene blue helps preserve neurological function and reduce disease progression. The protective effects of methylene blue are closely linked to its ability to activate a critical cellular pathway, the AMP-activated protein kinase, AMPK/silent mating type information regulation 2 homolog 1, SIRT1 pathway. Both AMPK and SIRT1 are vital for maintaining cellular energy metabolism and play significant roles in regulating inflammatory responses. AMPK is a master regulator of energy balance within cells. It can activate SIRT1, which in turn modulates inflammatory responses by suppressing a protein complex called NF-kappa B, NR-kappa-B is a major driver of inflammation, so its suppression is a powerful anti-inflammatory mechanism. This synergistic relationship between AMPK and SIRT1 makes this pathway an attractive target for treating inflammatory diseases. Beyond its direct anti-inflammatory effects, methylene blue also influences the delicate balance of the immune system. In autoimmune diseases like MS, certain types of T cells, particularly pro-inflammatory T helper type 17, Th17 cells, are overactive and contribute to tissue damage. Conversely, regulatory T cells, Tregs, which help suppress immune responses, are often dysfunctional. Methylene blue treatment has been shown to alleviate Th17 responses, reducing the number of these harmful cells. Simultaneously, it increases the number and function of regulatory T cells, Tregs, promoting a more balanced and less destructive immune environment. This immunomodulatory effect is a significant aspect of MB's therapeutic potential. The neuroprotective properties of methylene blue extend beyond MS. It has been successfully used to treat conditions like methemoglobinemia, a blood disorder, and ifosfamide neurotoxicity, a side effect of certain chemotherapy drugs. Recent studies also highlight its potential in Parkinson's disease and ischemic stroke. NB can act as an alternative mitochondrial electron carrier, improving cellular energy production and protecting neurons from damage. This broad spectrum of action underscores methylene blue's versatility as a therapeutic agent. The research on methylene blue is incredibly promising. Its ability to cross the blood-brain barrier, mitigate inflammation, activate crucial cellular pathways like AMPK, SIRT1, and modulate immune responses positions it as a potential game-changer for neurological disorders. While current clinical uses don't involve visible brain coloring, the microscopic and cellular effects are profound. These findings suggest that methylene blue could be a powerful new tool in our arsenal against autoimmune diseases and neurodegenerative conditions. Continued research is essential to translate these exciting preclinical results into effective and safe treatments for patients. If you or a loved one are affected by neurological conditions, stay informed about the latest research. Consult with your healthcare provider to discuss emerging therapies and clinical trials. Share this information with others who might benefit from understanding the potential of compounds like methylene blue. Your engagement and awareness can drive progress in medical science.